All right, so we have water undergoing a process from 1 bar and 1 meter cubed to a bar to 1 bar and 120 degrees Celsius. And we want to figure out the changes in internal energy and then enthalpy. And then also we want to draw the process on a TB diagram. So let's go ahead and write what we do know. Um, let's go with green. I don't know. So, so we have water. And let's write what we know about state one. So state one, we know the pressure is 1 bar. We know that the specific volume is 1 meters cubed per kilogram. We know P2 is also 1 bar. And oops, there we go. T2 is 120 degrees Celsius. So the first thing we need to do is get all the unknown properties. So we need U's, H's. We're also missing specific volume from state 2. So let's go ahead and figure out at state 1, what phase are we in? And so for state 1, first thing that we need to do is go to our saturated tables that are organized by pressure because we know pressure and figure out using the information there, what phase are we in? So I can see, stab at. So I could see that at 1 bar, we are between, at specific volume of 1 meters cubed per kilogram, we're between the V sub F and the V sub G. So that's good. That means that it's saturated. And again, I know that because we're between the V sub F and the V sub G value. And so that tells me that I need to figure out a quality, right? And I need to figure out a quality because, well, let's see, because my internal energy and my enthalpy are going to depend on it, right? This is going to be my H sub F plus my quality. Oops, I'm sorry, not H, my U sub F. U sub F plus my quality times U sub G minus U sub F. And it's actually, let's just focus on the specific volume here. So let's go ahead and write down at least the numbers that I do know. So I know this guy and I know this guy. So maybe I'll go ahead and at least plug that in. So this is 417.36. I'm going to put the brackets such that I can write the units on the outside so I could be a little bit lazy. So plus whatever that quality is, I don't know what it is, times, I have to probably bring it down a little bit. So this is 2506.1 minus 417.36. There we go. Kind of messy, but that's okay. Kilojoules per kilogram. So I do need to figure out whatever that quality is. All right, so let's go ahead and figure that out. So the thing that I'm going to need is my specific volume, right? Because remember, if you know two independent intensive properties, you can figure out anything else that you need to know. So I have pressure and specific volume, which are intensive, always independent of one another. So I know I could figure out that quality. Well, I know that the quality is also governed by that sort of relationship with quality. So it's going to be V sub G, is V sub F. So that means that my quality is going to be V1, which I know to be 1, minus my V sub F, which is this guy, 0.001432 over my V sub G, 0.694 minus my V sub F, 0.001. And actually I'm missing a 0, aren't I? 0.432. Perfect. So I end up getting a quality 0.59. Actually, no, I'm sorry. Just kidding. 694. Yep, 0.59. And so now I can plug, I know this guy. So now I can plug that guy in. So I get a final answer of, let's see, 1649.9. Perfect. All right. Let me go ahead and I'll at least highlight that because I'm going to need that information. And then we'll go ahead and get our enthalpy in the same manner. So I've got H1, H1 equals H sub F plus my quality times H sub G minus H sub F. Okay. Now, here's my H sub F. Here's my H sub FG. You also notice that you've got a column for H sub FG, so you could use that as well. That's just H sub G minus H sub F. It really doesn't matter. But again, we've got these guys, right? Oh, actually gonna, there's that thump. Those are the numbers that I would plug in, or you could use that H sub FG if you want to. You should get approximately the same thing. So I end up getting 1749.9. It's kilojoules per kilogram. So there's our H1. Perfect. Awesome. All right. So I've got state 1, everything that I need about state 1. Now I need to go to state 2. So state 2, they tell me it's at 1 bar and 120 degrees Celsius. So the first thing that I would do is I would go back to those saturated tables to figure out what phase that we're in. So at 1 bar, it looks like, well, that saturation temperature is 99.63. We're at 120 degrees Celsius, which means that our temperature is above the saturation temperature at 1 bar. So I know that we're superheated. So I need to go to my superheated tables. And so it's in my superheated tables at 1 bar. So 1 bar, 120 degrees Celsius. I've got specific volume, internal energy, and enthalpy values that I can pull off the table. So I've got this guy, and this guy, and I need all of them because I'll need to draw things on my TV diagram as well. So I do need that specific volume. Oops, and it's not state 1. We're at state 2 already. Perfect. So this is going to be 1.793 meters cubed per kilogram. My U2, 2537.3 kilojoules per kilogram. Did I say kilojoules? This one's meters cubed per kilogram. I don't know if I said kilojoules per kilogram before. And then this guy is 2716.6 kilojoules per kilogram. And so what I was really asked to find was the changes in internal energy and enthalpy. Easy enough. I have everything I need here, right? So again, anytime you have a delta, it's what it is after minus what it is before. So my delta U, 887.4 kilojoules per kilogram. My delta H is 966.7 kilojoules per kilogram. Perfect. So that is mostly what I needed. And then the very last thing that I need is I need to draw things on my TV diagram. And I've actually already done so, so it's nice and neat down here. So let's kind of walk through what we see here. So we have our vapor dome. Remember, state 1 was 2-phase, so it's underneath the dome. State 2 is superheated, so it's to the right-hand side of the dome. Remember, our pressure was constant, so I drew a line of constant pressure such that it passed through state 1 and state 2, and that's how I kind of like was able to gauge where state 2 was in relationship to state 1. I've drawn the specific volume or labeled the specific volume. I've labeled here's T2. T1, remember, is this one is 99.63. So the reason it is because we're saturated at 1 bar, and 99.63 is the saturation temperature at 1 bar. So if this were given to me on a test, I would get full credit because I've drawn my vapor dome, got some units here. I've drawn state 1 and state 2 in relationship to the dome correctly. I've drawn it along the right process path, and I've drawn that process path clearly, and I've labeled the coordinates, right? I've labeled the temperature and the specific volume on my axes. Okay. All right. Well, I hope that it was helpful. Thank you for watching. Let me know if you have any questions.